All right, welcome back. So now that we have our player, Cube, just kind of sitting there, it's time to bring this guy to life.
Okay.
In this video, what we're going to do is take a look at scripting. We're going to create our own custom component that we will be adding to our player here that will enable us to read input from a user that's playing the game and make this guy move back and forth. But more importantly, in this video, you're going to see for the first time how we would go about creating a script that we could then turn around and attach to our object.
So we're going to be doing some programming.
So we're going to be doing some programming. And on that note, let me spend just a second and talk about programming. We may have some viewers out there, Zach, that aren't programmers.
Oh, no.
And you might kind of fall in that category as far as any language that requires a compiler.
Yeah, I have to admit, I do a lot of stuff in MaxScript and MelScript, but if you have to hit a compile button, my brain kind of shuts down.
Well, it's actually going to be pretty easy. I'm going to do the best I can to make everything clear here. But I just want to point out that I'm not going to stop and start talking about things like inheritance and what instantiated classes are,
sure,
et cetera, et cetera. But I would like to point out that over on 3DBuzz.com, we have created an XNA series. There's actually quite a few of them out now. We got XNA Volume 1, 2, and 3. Mm-hmm. And with XNA Volume 1, there's a large portion, at least 10, possibly 11 hours of it, that is freely available. So you can head over to 3DBuzz and create yourself a user account, which is absolutely free, and then jump in and start watching those Volume 1 videos. If you're new to C#, we're going to talk about getting C# up and running. Now, they're a little dated. I believe at the time when those were created, we were using Visual Studio 2005 Express, but it doesn't matter. Everything's still going to apply. The Hello World project that we make available for everyone goes way beyond a standard Hello World project.
Well, it's actually a full game.
It really is. We walk you through the creation of a text adventure game in which Zach wrote the underlying story and all the decisions you have to make. But we cover a lot of stuff. And throughout those videos, we continuously remind our viewers not to panic if they're new to programming. We just want for them to get in, follow along, get their hands dirty, and get exposed to some of the terminology.
Now, do you consider those videos to be a prerequisite for what we're about to do here in Unity?
They are not. I just, if you're new to programming, I highly recommend that you take a little bit of time and you can go to Microsoft, you can simply Google C#, find some introductory tutorials, do a little bit of reading. If you are new to the concept of object-oriented programming, it's very important that you at least have a basic understanding of working with objects and what properties are, data members, behavior, etc. Because all of this is, it's all underlying themes when working with C# and you're putting your scripts together, because we're going to be working with all of this stuff.
Absolutely. And while we're doing this stuff here on the Unity videos, I mean, you can type what we type. You can run the whole thing in monkey see, monkey do, but if you really want an understanding of what's going on under the hood, there is going to be a little bit of additional research required on your part, because these aren't programming videos.
That's right. But the good news is everything we're going to be doing throughout this simple game is pretty easy.
Cool.
Actually very easy. So I'd like to point out that by default, when you're working in Unity, the scripting language is JavaScript. I am using Visual Studio. In fact, I'm using Visual Studio Professional 2008. Now, if you happen to have the Visual Studio 2008 Express, that's fine. It'll work with it just as well. There's a couple little things that won't work, such as in your console dialog or a panel that you guys saw earlier. If you get an error, you can't double-click it and it take you over to that line inside of Visual Studio. This isn't the guys behind Unity putting this up as a, sorry, you've got to have the full-blown thing to do it, meaning professional. That's not the case at all. When you're working with Visual Studio Express, Microsoft has basically blocked off some of the hooks into it.
Sure.
With the intent of, if you want to get more professional, get the professional version.
Makes sense.
So, but everything that I'm going to be doing, you can follow along with absolutely fine.
Okay.
So, with all of that said and behind us, let's go ahead and get started. Again, we're going to be creating a script. So This script's not going to be a game object that we're going to come up here and add to the hierarchy. It's going to end up being a custom component that will be added to our player game object. So we're going to come down here into our project panel, and this is where we're going to create our script. But we need a folder. So I'm going to right click, come up to create folder, and let's call this guy scripts. Keep everything nice and organized.
Oh, yeah.
So now what I'm going to do is right click, come up to create again. You can see JavaScript, C# script, Boo script. So we've got these 3 different types of scripting languages that we could work with. Now, when Casey Jones put this example game together, he used the default JavaScript. And again, the reason I'm paralleling what he did is I'm simply reproducing it using C#. So let's go ahead and select C# script. So we've got a new script in. There's a couple things I'd like to point out. First of all, if you've played with Unity before and you've not worked with C# scripts, but you did play with the JavaScripts, you'll notice that there is definitely a difference in the way things look. We can actually see the class and who we inherit from, where that's not something you're going to see when you're working with the JavaScript that gets created when you right-click and add a new script.
So is it just a syntax difference?
Well, I mean, it's a language difference.
Yeah,
They're
okay.
different languages.
Right.
So here, first thing I want to do is go ahead and name my script. So let's go ahead and click on it, and I'm going to call it player. I'm just going to have it simply match my my object, my game object. Now, you got people out there that like to do things like player script.
Sure.
And or S_player. And there's nothing wrong with it as long as you come up with a naming convention that you stick to. And if you're working with a small team of people, everybody is agreeing on. That's the key thing is consistency. In my case, when I come up with my my scripts, I generally use the name of the object that it's going to be attached to, unless it has some other very specific type of behavior that it's going to be responsible for.
Okay.
So we've got it as player, but take a look at this. The class is called new behavior script. So the name of the class did originally match the file name that was created, because this is actually a CS file that has been created in the scripts folder up under the assets folder in our project. If I try to take this guy right now, drag and drop him up on player, it's not going to let me because it's expecting my class name here to match my file name. So let me click and try just to show you guys. So drag it up, drop it on player. We get the dialog saying can't add script. And this is because can't add the script behavior player because the name does not match the name of the class. So we need to fix that. So this is where I'm going to open up Visual Studio, which is where I'll do all of my scripting work, of course. Now, I'd like to point this out. When working with Visual Studio, as a matter of fact, if you guys give me just 1 second, actually, let me just do this and then I'll pull it up. I'm going to right-click on player. This is the important thing to understand here. I'm going to hit Sync Visual Studio Project. And the reason I'm doing this is I honestly cannot recall if in standard Unity, if it will automatically sync when you double click to open up a file. Only because I've just been steadily working with Professional.
Yeah.
Exactly. So hey, I'll be honest, I just don't remember. Plus, I haven't worked with 2.6 standard at all, to be honest. And it is with 2.6 that they added the ability in to work directly with Visual Studio. What's going to happen when you click on the Sync Visual Studio project, which you can right-click and select from a script, or you can also come up to Assets and get to it from up here.
Okay.
What's going to happen is a solution file is going to be created, and that is a Visual Studio solution file, in your project folder at the root, so at the same level as your Assets folder and your Library folder. So if we were to jump down here and open this guy up, so here we are in Unity Projects, VTM Content. Inside our simple game, there's Assets, Library, etc. Here is the solution file that was just now generated.
Just like as if we were programming this inside of Visual Studio.
That's right, and we had created a project over there.
Right.
And this solution file, of course, is going to have all of the files that we're going to be working with inside of Unity. Everything keeps organized. So the idea is that we want to keep our solution file synced with the files that we add back over here inside of Unity. Now, what's really nice is from inside of Visual Studio, if we add files there, Unity is really slick. Unity is going to pick those up automatically.
Gotcha.
So that is generally where I'm going to add files. We're going to come back to that a little bit later because I want to show you guys how you can create a template. So instead of having to right-click and create your scripts over here, you can just add a new Unity or mono behavior script inside of Visual Studio and just stay working over there all day long.
And they'll just pick right up.
And it'll just pick right up, which is fantastic.
Now, what you were saying earlier is that you can potentially double-click on that script here inside of your project panel, and it will sync, but you also right-clicked on it?
I did. Mm-hmm. And the reason is, once again, I simply can't remember if with standard, if double-clicking it is going to give you the dialogue and sync things up. It may just be pro only.
Okay. Either way, it's just safer to right-click and choose it directly.
Well, to be honest, in standard production, I will right-click and sync it all the time anyways, if I've added something over here since I've been in Visual Studio, because I have a couple of times in 2.6 have had it to where I've double-clicked and it's not synced up properly.
Gotcha.
So I don't know if that's a bug. I'm not sure what happened. So I've just got into such a habit of I just always sync, double-click, and then... So there we go. It opens up, and now I am looking at my file.
Very nice.
Okay? And you can see it's got my directory structure showing up here with asset scripts, and then there's my player.cs file. Now, first things first, let's go ahead and change this name from new behavior script over to player. Now, if we were to save it, the moment I click back over here into Unity, this thing's going to be analyzed and compiled, if you will. So let's go ahead and click back over here. If we had any problems with the script, an error would have shown up over in our console, and we would have also seen the error down here.
Okay.
But everything's cool. There's no problems. But we can try something now. Let's grab player, drag it back up here to our player game object, let go.
And it just works.
It just worked. It gave me no errors. And now when I select player and I start looking at all of the different components that have been attached, down here, you will see that I now have a new component that has been added, and this is my script component player. Okay?
Okay.
So now that we have it in place, let's jump back in here. Let's point out another thing that is very important, and that is we also have help.
Fear not the help file.
The help file is so important. As a matter of fact, before we start doing some coding, I'd like to show you how important it is. Let's jump back over here to player and take a quick look at what we have for our script so far. So we've got using the Unity engine. So now, as we begin coding, everything that exists inside the Unity engine is just accessible to us. So all of a sudden, code just understands. If I wanted to say destroy something and type out the word destroy, it's going to know, hey, I know what destroy is, because destroy is inside of the Unity engine, and since we're using it, it's right there at our fingertips. We're also using system.collections. We don't really need to use that at the moment, but if we wanted to use like array lists or something, we have that at our disposal. But here's the big thing. We have a public class called player that inherits from mono behavior. So mono behavior is our base class. That's who we're inheriting everything that is protected and public from this guy. He has several very important things that we're going to be inheriting, such as a bunch of overridable functions. And here's what I'm talking about. We've got a start function and an update function that have already been set up in a template here for us to utilize. And some comments. Use this for initialization. So we'd put some code in here on initialization for our player script. And then update is called once per frame. So if there's something we wanted to do every frame, we could add the code in here. Outstanding. But where do these come from? I hate things that just appear magical. I like to understand where things come from. Well, since we're inheriting from mono behavior, and mono behavior is, we're now getting back to Unity itself. Here's a way of looking at it. You can look at it as Unity has hooks into mono behavior, and then there are functions that exist in mono behavior that are virtual that we can then override to put our own functionality in. And as the Unity engine is hitting that functionality, that just kind of trickles down to us, the actual component attached to the game object, and our code executes.
Okay.
So I want to see start, update, and what other functions are available to me. So what I'm going to do is I'm going to actually jump down here and open up my browser just to point out to you guys that we also have help available to us online. Just showing you, there's help all over the place. Use it. So here inside the help, which is actually the same thing that you'd have inside of Visual Studio as well.
Yeah.
What I want to do is come down here to runtime classes, because our player is a script that's going to be a runtime type class. And he's inheriting from a class that is obviously a runtime class. So from inside here, let's find mono behavior. That's who we're extending, right? Because we're not going to find player in here. Player is our own custom thing.
Yeah, we made that up.
So as we come down to the world of object, and we start digging on in, we find mono behavior. Or you can use Control F and just type it in.
I was going to say, I would just have to search for it. I hate lists.
So let's go ahead and click on this. And here's what I want to point out. So mono behavior, it's the base class, every script that derives from. And I would like to add my own comments to that. Yes, it's the base class that every script that will be attached to a game object will derive from. Okay? But that does not mean that you're limited to every single class having mono behavior somewhere back up in its family tree as the base. Meaning you can still create your own custom classes in C# that are not going to be attached to a game object.
Okay.
That have very specific functionality, and your game objects may interface with those classes for one reason or the other. And I actually have planned, and it's just a matter of time, redoing this simple game with a different structure, a structure that follows a few design patterns. And with that, you're going to see some very interesting things. And again, that's just time, depending on time. So anyways, inside here, what I'm going to do, let's look down to overridable functions. I guess I got to select from right to left. There we go. So functions that I can override. So these guys, once again, are all kind of hooked into Unity. So Unity is going to make sure these guys get called at the appropriate time. But there we go, update. So update has now been checked off the list. He's no longer magical. Update's called every frame, just like it said back in the comments. If the mono behavior is enabled, okay? We're going to get into enabling and disabling a little bit later on.
So keep it simple for now. It's just something that gets updated all
the time. It is. When we apply this, it is enabled until we go in there and disable it. So with this component enabled, update's getting called every frame. Now we have some other updates that we could put in there, but they're not there by default. Now start. That was the other magical function that just appeared and somehow knows to get called there at the beginning. Here we are. Start is called just before any of the update methods are called for the very first time.
Okay.
You have another one in here that I like to use often that's called awake. And awake is going to get called when the script instance is being loaded. So look at it like this. Awake gets called first, then start gets called right before that first update. And then you get your update every frame.
Gotcha.
We also have other things in there that we can take advantage of. So if you wanted to track a mouse coming over or exiting out, you can use on mouse enter, on mouse over, on mouse exit, down, etc. Very handy. And once again, for having Unity, which written in its native language, much faster than scripting language, having it make calls to this stuff as opposed to you tracking the mouse location and update every single frame. A lot slower. So as we scroll down, you'll see we do have quite a few functions that we have the ability to override.
But by default, we got our update function and we got a start function. Currently, they don't have any code in them.
That's right. We received those from mono behavior. So this did this to me earlier. Let's give it just a second and see whatever it's saving, doing, or I'm not sure. Let's let it finish real quick. And yeah, for whatever reason, I have faith. Zach's over here shaking his head no, but I'm not 100% sure what the machine's doing at the moment. So still do not have functionality back, and there we go. Yep, not 100% sure, but we have functionality back. Let's continue going.
All right, cool.
Okay, so now what I'd like to do is let's get some code in. Let's just take a look at how we would go about manipulating our player.
Okay.
So I'm going to, and I know those of you out there that are professional programmers or have been programming for some time are used to having your braces start right after the declaration or of the function itself.
Sure.
This just goes back to anything that I present in video format or when standing up lecturing in front of students. I always try to organize things like this. I just found that teaching, it helps. It helps keep things more organized.
Oh, it's funny. That's how you taught me to use Mel years ago, and it's still how I code to this day.
Oh, is it really? Yeah, it's weird because when I'm teaching but I'm coming off of the programming gig.
Yeah,
I have a hard time remembering to straighten these guys up. But so, anyways, I'm just doing that just to keep everything nice, organized, very linear when you're reading down the script.
Sure.
Okay, so in Start. Let's start out by having our player, when we launch the game, I want to see the game begin and the player actually appear somewhere else. Okay. So right now, our player, as we know, is located at 0, 0, 0 in the world. So let's play with him for a second. So if we were to take a look, let's come over here. Actually, with him selected, let's just go ahead and frame up on him, or focus up on him. So we can slide him left and right, and we can see down in our game panel that, we can see him move. So over here and maybe up here, that'd be a good place to have him start off at. So I'm just going to use a pen and jot some numbers down real quick. So let's say about -6 in X, and I'm looking right here, and about 5, we'll just say 5 in Y, okay? Now, let's zero him back out. So we know that we want him to start when the game starts. That's where we want him to actually begin.
Sure.
So how do we go about telling the script to do this? Well, first of all, what do we want to manipulate? We want to manipulate the transform component of this game object. So we've got to talk to the transform. Now, once we begin talking to the transform, we now need to step down because there's different elements of transform that we can talk to. We can talk to the position, we can talk to the rotation, and we can talk to the scale. I want to talk to the position. And then even more specifically, I want to talk to the X and I want to talk to the Y components. So let's go ahead, jump back over in here, and see how we would go about doing this. So first thing, I want to talk to transform. Look, transform, there it is. And yes, it is just that easy. Now I'm going to hit dot and let it finish typing out transform for me. And then here are all of the different things that I can now talk to up underneath transform. And as we said, the next thing is going to be the position. Okay. So there's position. Now, if we were to hit dot again, you'll notice we now have access to X, Y, and Z.
Gotcha.
And if you're working over inside of JavaScript, you can just say .x equals and give it a number. But transform dot position is referencing a vector 3. Okay, a vector 3 contains a float, and a float. Those 3 floats are X, Y,
and Z.
That's right. So in this case, what we're wanting to do is we're wanting to create a new vector 3 object that we're going to reference. So instead of saying just .x, because I can't get away with that, I'm going to say we're going to make a new, and look at this. IntelliSense pops up and says, hey, you want a vector 3, don't you? Because it knows that that's what it's expecting.
Yeah.
So please keep in mind, Visual Studio is actually here to help you, and it's going to do a pretty good job of that.
Nice.
So, okay, vector 3, nice. Let's go ahead and open up, and now it's letting me know we've got 3 overloads for it. So we can come in here, we can just give it an X and a Y, or we can give it an X, Y, and a Z. So let me start out by positioning it where I just indicated back over in the scene when we physically drug out. And if you guys recall, we said we were going to position it at -6 in X, 5 in Y, and you'll notice you can see which component I'm referencing. As I'm typing, it's making that particular component bold, comma, and now we've got Z. And for Z, I could just leave Z at 0. Or, Zach, tell me what you think I'm doing when I do this. If I come back in here and say transform dot position dot Z.
Setting it to whatever it is already?
You got it. That's very, very important. So in this case, let's just say that the Z location of our object was at a very specific place, and we didn't want to change that. So obviously, we wouldn't just type 0 here. And in our code, perhaps we didn't know where that location was based off of events that have occurred in the game. So by simply doing this, that is going to leave the Z property untouched.
And before anybody out there is like, well, this is an orthographic game, it's two-dimensional, why does Z even matter? You could use this for layering. Having one object that's further back from the camera than another will give you the ability to put one object literally on top of another from the player's perspective.
That's right. So this right here, this is how we simply go about assigning a new position to our object.
Okay.
What we're doing is we're assigning this new position in start. So when I hit play, when our game executes in the game panel, we should see our cube start at this position.
So no matter where it is, when we're actually sitting inside the editor, as soon as we hit play, it should jump to the upper left corner in this case.
Yep. So I just hit Control S to save, because we got to make sure we save before we jump back over here. So I've jumped back over. The compiler's done its thing. As a matter of fact, we even see a warning down here talking about line endings, difference between working with Mac OS X and Windows with a different line ending. Don't worry about that. That's something we can clean up later. In fact, Visual Studio will even ask you about cleaning up that as we progress forward. And that only occurred because we created the script originally in here, which used a template that had the line ending that is slightly different than what's expected over when working inside of Visual Studio with Windows.
Okay.
Don't even worry about it, all right? So now that we have our scripts applied, we have some code in the start, and if we click on player now, you can see everything's updated. We can actually see that code in here.
Yep.
If I hit play, watch what we get. Boom.
Nice.
As soon as the game began, that is where he's located. And if I was to come up here, select my player, he is at -6 by 5. Now, while I'm right here, let me point something else out too. And that is that you can manipulate these numbers in the inspector while your game is running. This is awesome. As you manipulate these numbers, you can see the effects that it will have on your game object. Nothing is being remembered, meaning the moment you hit stop on your game, everything resets back to what it was before you hit play.
Okay.
So that's very handy to be able to come in here and go, oh, let me try a different position, or let me try a different position over here. Oh, maybe I like that a little bit better.
Sure.
As soon as I hit stop, whatever this guy was at before you hit play is what he resets back to.
Oh, because at this point, start hasn't been called yet.
That's right. At this point, we're no longer playing a game. We're back in the editor, so we're back to what we were at before we hit play.
Okay.
Okay, so now that we have a quick example, let's jump back over here into Visual Studio, of how we can take our object and position it, it's time for us to move on to how do we go about manipulating it in regards to a user controlling, keyboard input, and that keyboard input in turn causes our guy to move. And that is what we're going to take a look at in the next video, only because I looked down and we've gone for almost half an hour. So this video has gotten pretty long. So let's try our best to keep things short. Wrap up here, because this was a good introduction to getting our first script created. And in the next video, we'll get that motion into place. So let's go wrap up this video, guys. See you in the next one.